question number 101. But before that, you should know that from question number 100 onwards, the questions are assertion and reason type, and in that case, if both assertion and reason are true and the reason is the correct explanation of assertion, then you need to mark 1. Similarly, if both reason and assertion are correct but reason is not the correct explanation of the assertion, then you need to mark 2. If assertion is true but reason is false, then mark 3, and if both assertion and reason are false statements, then mark 4. So we need to check the given statements first of all. Now here in question number 101, assertion is CuCl is more covalent than NaCl. If I talk about CuCl, Cu positive ion is there, and in case of NaCl there is Na positive ion. And if I talk about the charge to radius ratio, that is more in case of Cu plus, because in this case large atomic size is there, 18 electrons are present in the valence shell also, and that is why the Cu plus has more polarizing power as compared to Na positive, and that is why CuCl is more covalent. So let's check the reason also. Reason states polarizing power of Cu plus is more than Na positive. Yes, the reason is correct, as well as it is also explaining the assertion. So which option you will choose for this question? Definitely answer would be option 1. After this, question number 102. Assertion is ammonia is more polar than NF3. First of all, I need to just draw the structures of both ammonia and NF3. The similar structure, both of them have the same type of lone pair is present in the unhybridized orbital. Now, in this case, lone pair moment is in upward direction, similarly here also. But if I talk about the bond movement, that is in opposite direction in case of NF3. What happened in NH3? In case of NH3, the bond dipole is towards nitrogen atom, being more electronegative. Similarly, if I talk about nitrogen and fluorine, fluorine is more electronegative. That's why the bond moment is towards fluorine in this way. So what will happen? The moment due to lone pair is cancelling out the bond moment here, and that's why in this case polarity is decreased, dipole moment is decreased, and in this case the first statement is correct. Ammonia is more polar than NF3. But what about the reason that's given here? Lone pair moment partially cancels the resultant of NF bond moments in NF3. Yes, very true, because in this case you can clearly see this is the lone pair moment, and that is partially cancels the resultant of NF bond moments, and that's why this reason is correctly explaining the assertion also. It is correct as well as it is explaining also assertion. So option that we'll choose here is option 1. After this, 103. Assertion is beryllium and magnesium are kinetically inert to oxygen and water. We know that both beryllium and magnesium are showing diagonal relationship, and yes, it is a correct statement that both of these are kinetically inert to oxygen and water. Now, reason is beryllium and magnesium form protective oxide film on their surface. It is also true. Both of these statements are true, and reason is correctly explaining assertion also. So which option I should choose? Again, first option. After that, question number 104. Assertion is interhalogen compounds are more reactive than halogens. If I talk about interhalogen compound, these are the compounds which are formed between two different halogens. And if I compare stability of halogens and the interhalogen compounds are reactive, less stable. Reason is the bond strength. In case of halogen, the bond between the two halogen atom is stronger as compared to the bond present between two halogen in interhalogen compound. Let's check the reason also. Reason states XX dash bond in interhalogen is weaker than XX bond in halogen except FF bonds. It means in this case reason is also correctly explaining the assertion. Both the statements are correct. Reason is explaining assertion. That's why option becomes option 1. After this, question number 105. Assertion is Frankel defect is a non-stoichiometric defect. It is incorrect statement. Why? Because in case of Frankel defect, one of the particle from its side is moved to the interstitial side, and that is not changing the stoichiometry. Further, due to Frankel defect, the density of the crystal decreases. In case of shifting of the particle from the original lattice side to the interstitial side, there is no change in density. It means both assertion and reason are incorrect statement. So which option I should choose here? Definitely option 4 I'll choose for this question. After this,